That's not right. Almost negative.
I don't know on this one.
I am not sure because I saw this example, and what he did is when it was a log minus a log that had.
So if we solve these individually, so just for a second, remove the minus the log of x minus 1. Like, it can get us close, but if we use the definition of a logarithm, then we can rewrite, say, log of x is equal to 2. It'd be 100 is equal to x. But I don't know how to...
Well, on this one,
100 minus 99, but I don't know how to make that divided by.
Did you guys hear that?
what?
Peter
Peterson
said.
Yeah.
So he said if we solve them individually of logs, log of x equals 2, well, the x is going to be 100 for the first one. And then if you take the second one, log base 10, x minus 1, if you rearrange it, that equals 99. You get 100 minus 99 to be 100 divided by 99. Unless you add log base 10x plus 1 to the other side.
Wait, what are you trying to figure out right now? Okay.
What x is?
Because the answer is 1.01.
Yeah.
Okay.
So I did it. I mean, I found a way, and I got 1.05 because I got 20 over 19. But I can't. I haven't gotten. I don't know how to get any closer than that.
Actually, I think I just figured it out.
Okay.
So you would put the x over x minus 1, but you would set it to 100 because it'd be the 10 raised to the 2. And then you solve it from there, and it equals negative 100 over negative 99, which is 100 over 99.
Okay, so
which would be 1.0.
You set both sides, so you set 100. What do you do to the side with the 2 then? Because that's the part that's screwing me up. Because I just watched this video, and what he did is he had log of x divided by x minus 1 equaling whatever, equaling 2 in this case. And then to get rid of the log, he just timed both sides by 10.
Yeah, what you would do, since it's a log base of 10, you would put the 10 on the other side and raise it to 2. So that would be 100.
Oh, okay. That's where he threw me off.
Yeah.
Okay. That makes sense then. And then it would just be x over x minus 1. Yeah. I'm inclined to agree with Claire here. minus 99x divided by 9. Yep. All right. Everybody get that one?
Yeah.
The way she was explaining it.
All right. I think they're moving on.
All right.
So,
Did everybody get that, or
Yeah, I figured it out.
okay? X plus 3.
so how are we supposed to do this one? Do you guys know?
What do you mean this one? The fourth one?
The fifth one. Oh wait, are we on the fifth one or the fourth one?
Pretty sure we're just on the fourth one.
Oh yeah, the fourth one. Can we add an e to each one of those ln's?
I wonder if you can divide out these ln's.
So then you're left with the ln of x equals x plus 3.
No, what I just see here with what he's doing is it's still, well, that's a subtraction. Never mind, keep going.
Austin, what are you seeing on your example?
Hold on. I'm trying to do some, just real quick. Let me work through this. Dang it. I didn't get it. Close, but not it.
Bless you.
Um,
Because on the other one, so in the example, they were minus, so it's not exactly the same. But when it was so 2 ln x, I think what that is ln x squared. That's what he showed in the example. When you put a number outside, like 2 ln x, it just means you can change it to ln x squared.
Okay.
So then I changed it to ln x squared equals all of that. And then I wasn't sure if at that point you could divide it all by L of n, which I don't know if you can because it's not multiplication, it's addition. And then addition, I don't know how you set it up because when it was x plus 3, minus x minus 1, you could just do x plus 3 over x minus 1. But because it's a plus, I don't know if you're allowed to set the first one over that or if you flip-flop it or what you're trying to do. So that's what I'm trying to find out right now.
Okay.
You multiply them together, that's the difference. So you should have ln x squared equals ln x plus 3 times x minus 1.
Shouldn't that be ln of x plus 3 plus x minus 1?
No. Hold on, let me make sure I'm doing it right. I think I got it.
Emily just left.
Yeah, so I got it. Okay, so here's what we do. Can everybody hear me? Well, except Peter, I guess, if he's on a different set.
Here,
Peter, can you hear me?
explain.
Okay. So on that one, does everyone understand that 2 of L of n changes into L of n x squared?
Yeah.
Does everybody get that? Like that's a thing? Brennan, you're muted. Well, anyway, Claire, I'll talk to you then. So the ln goes to x squared,
Okay.
right? And then on the other
can hear you,
side,
Austin.
since it's... Huh?
I can hear you. I just have myself muted because I'm explaining it to Peter as you're explaining it to us.
Okay, got it. Okay, good deal. So the L of n, does he understand that how it turns into x squared?
Yeah, I'm explaining it to him.
Okay, so anyway, so then you said it's equal, and since it's an addition problem and not a subtraction problem, it's the first set multiplied by the second set. So in this case,
Okay.
it'd be x plus 3 times x minus 1. Now, if it was subtraction, it would be x plus 3 divided by x plus 1. But obviously, it's not. So then you multiply that out and you get ln x squared equals ln of x squared plus 2x minus 3. And at that point, since there's no additions between factors on either side, you can divide the whole thing by L of n, and you get x squared equals x squared plus 2x minus 3. And then you can solve that algebraically, and you get x equals 1/2.
That makes sense.
And then let me know if Peter understands that or if you don't or whatever.
Yeah, we're working on it right now.
Good deal.
Peter, when you get to that point, then you divide by x, and so then or by ln. So then you get
Right, so it's x squared is equal to 2x plus.
Yeah, and then once you solve that algebraically, you come out with 3 halves and 3 halves and one and 3 halves. That makes sense.
As soon as I get there, you guys didn't solve it by factoring.
There shouldn't be. Wait, factoring. I don't know if there's factoring in this.
Okay.
Perfect. So are we on number 5 then?
Yes.
Okay. So this one, I just think we need to rearrange it.
Yeah. Okay.
Right?
It looks like
Or the main number becomes the base of the log.
yeah, so
And then the answer is the main number. So on this one, I think we just need to do the opposites. So instead of multiplying it by -4, you divide by +4. And instead of adding -1, you add 1.
right. It makes sense. Like all you have to do really is look at the answer sheet and it can make sense. The hard part is trying to understand that that's how it is. Because you have the 1.02, which is your base pair if you're looking at logs. And then the 5 is the number that it is of. Now, I don't understand exactly the +1. I can understand that's a rule if that's just what you do. Because I guess it is your exponents. Okay, because you're... No, explain that one.
Because if you look at the answer, it makes sense, but
Well, that's what I mean. Yeah, it makes sense, and I can understand how they got there. It's just a matter of, like, that's one of those things. How do you know 2 + 2 is 4? Well, you just know it.
yeah.
I wouldn't know what else to do with the
I just say we take it for what it's worth, and that looks good.
Yeah.
deal. All right, number 2.
All right, we're moving on to number 2 then.
Perfect.
If $5,000 is invested into an account,
So you just plug this into PERT, right? Or this
A
is
equals PERT, yeah.
the 5,000. 1
times
0.56
divided by 4 to the 40th power. Should be. Wait a minute. Oh. Wait. Huh? Did I not do that right? Oh, wait a minute.
Yeah, so that first one should be 8,719.
What was the equation? For some reason, I'm having a brain fart.
Yeah, so it's 5,000 parentheses 1 plus
Oh, the 1 plus. That was where I was stupid at. Right. Okay.
0.056 divided by 4 to the 40th. And that
Yep.
comes
Got it.
8,719 and 43 cents.
All right, and if it's compounded continuously, that equation is the
It's 5,000 times 1 plus, what was it?
0.056 divided by 4.
The power of
40.
whatever,
40.
5.6. I'm sorry, go ahead.
It's 10 times 4 because it's 10 years and it's compounded four times a year. And then continuously, is that by 365?
no, that's daily.
This one's,
Continuously is continuously.
Yeah, that's by 4. But there's a second part to the question.
Oh, gotcha.
Austin, what were you saying is continuously?
It's continuously, not daily. It's like every single second.
So it's continuously the PERT one?
Yes. Which is just 5,000. Yeah. So it's just 5,000 E to the 0.056 times 10. And then on the next one, all you do is you set the equation 4,000 equals 400 times 1 plus 0.02 divided by 4 to the 4x. And then you have to find out how long it would take.
So this one you would plug in the 4,000 for the principal, or for Austin. How do you do this one?
So what you do is you just go 4,000 equals 400 parentheses 1 plus 0.02 divided by 4 in parentheses to the 4x, and then you're trying to solve for the years because the 4 is the quantity.
What do you know you're doing?
And it says, oh, how long?
Hey Austin, so once you get to the 402 to the 4x equals 4,000, what do you do?
402 to the 4x.
Yeah.
What is the 400? What is the 2?
When I took 1 plus 0.02 divided by 4,
Right.
times that by 400, that was 402.
It's a lot easier if you just divide by 400 first. I mean, you can do it that way. Well, I guess, wait, what did you get? Sorry, 400 times what?
1 plus 0.02 over 4.
You got 402. See, what I did is I just divided both sides by 400. So I got 10 equals 1.005 to the 4x. Then I forget what to do from there. It should be like... It's going to take a long freaking time. It's pretty close to 115 and a half, right?
It's going to be like 470.
Yeah. I don't know the exact way to do it from there, other than like trial and error stuff.
Yeah, right?
Got a sinus infection.
Oh, dude, that sounds awful. Yeah, I do not envy you.
Yeah, me neither. Claire, do you know what you're doing on number 2?
I'm working on it.
Okay.
So how do you move exponents from one side to the other? That's all I need to know how to do. So I have 10 equals 1.005 to the 4x. How do I move that x away off the exponent and onto the other side on the like base and not an exponent? It's the only part I forgot how to do. Oh, wait a minute. Wait a minute.
Did you guys already move past that second one, or are you still there?
We're still there. Well, that isn't right. Hmm. I have no idea. I can, after I get it down to the 1.005 to the 4x equals 10, I can guesstimate. I guesstimated about 115.5. I have no idea how to actually like.
I say we just move on.
Yeah, I have no. I've looked for 1,000 YouTube videos. I got nothing.
Yeah.
So on number 3, the way you'd set that up is 6e to the 0.05x, right?
Yes.
And then from there, you just guess and check, right?
Well, that's all I. That's the only thing I know how to do. I don't know. I haven't. She hasn't given us a YouTube video or any information on that yet.
Yeah.
To my knowledge. I don't know if you're like supposed to move it or it's supposed to be divided by it or just move it to something or should be about 22 years. Roughly.
Because I found out the answer, it's 22, because when you plug it in up top, you just kind of start guessing and checking, and if you plug in like 20.
No, yeah, that's all I know how to
I
do.
figured out the second one.
How'd you do it?
Peter figured out number 2.
Yeah, how'd you do it?
Okay, so if you got it set up, 4,000 is equal to 400, basically times 1.005 to the power 4n. Divide the whole thing by 400.
Yeah, and so then
Right.
it comes out as what?
10
equals
plus
0.005 to the 4x.
Uh-huh.
Okay.
And then you apply the... damn, let me write it out here. And after that, we should be able to use the
No, see, yeah, tell them
algorithms
we
or
get
whatever.
there. I just don't know what to do from there.
All right, yeah, you guys keep doing that. I'm gonna keep working on this. I'm like almost there.
All right. So if you $2 million. 4,400. Okay. 1 plus X over. Go to the 200 power. 1 plus X over 1 is just X, right?
Yeah.
So how do you get rid of exponents? Does anyone remember how to do that? Do you have to like divide it by 200 and then divide the other side by 200, or?
Hey, Austin, on number 4, did you guys come out with 4,400 equals 1 plus X over 1 to the 200?
Yeah. So then on the X, so when it goes to the 200th power, do you just divide it by 200? Do you just multiply it by negative something? How do you get the 200 out of there without,
Don't you times both sides by the
1 over
inverse,
200?
so it'd be 1 over 200.
Is that what
Yeah.
you do?
That's it.
Okay.
So then 2 million to the 1 over 200th power.
I didn't turn on this stuff. Oh, you left it on? Okay. Okay. Okay.
That's not, I didn't get the right answer.
Hey, for the fourth one, set it up. 2 million is equal to 4,400 e to the 200 to the power of 200 times r.
No, it's not E. It's compounded annually.
I don't think it would be E because it's not compounded continuously.
The R I got was 1.27, so I did something wrong.
You're right. I got the right answer doing it that way, but
Oh, maybe that's why, because the answer I got doing it the non
I was
that way.
0.05 off. But if you round it up,
No. Tell Peter I think he's right and should put the wrong key in again.
E to the what?
200 times r.
Equals 2 million.
Yeah.
And then you divided everything by 4,400.
Uh-huh.
And so then 2 million divided by 4,400 is
It's 454.54 to repeating.
equals e to the 200r.
Yeah.
And then you took the ln of 454.
Mm-hmm. Which equals 200r.
I think he's right.
Divided by 200.
Yeah.
I think she put in the wrong key again.
So you took the ln of both sides?
No, just the 454. Because of that brings the 200r down from an exponent and gives her to the e.
Well, if you have ln to the e, those cancel out.
Gotcha.
So the ln of 454 is 6.1 equals 200r.
And divide by 200.
Yeah, you got it. Hey, Austin,
Yeah.
we got it.
Yeah, I figured after you guys were talking about it, because I plugged it back in my way and I get like 1 point whatever percent. 1
Yeah,
point
so
like
with
2
that,
something.
with that e, I'm wondering if it's continuous because it was compounded out over several years.
Yeah.
Anyway, so then number 3, as a team discussed different methods you could use to solve the following equation. Okay.
So what does she want us to do on this one then?
Well, you see those 2 like boxes on
Yeah.
the bottom there? They're the same equation, but they're 2 different ways of solving it. So I really basically
Just talk about the different methods we can use. I mean, that's what it says.
So are we just supposed to talk about it, or are we supposed to solve it?
Well, it solves it here, but I mean,
solved, and then just
probably
talk about the ways they solve and see if everybody understands them.
So are we just supposed to discuss it then?
I guess.
Because it looks like she just solves it for us.
Well, I know
Yeah.
she said talk about the different ways it gets
we're supposed
solved.
to talk about it.
Understand that there can be 2 ways to solve the same equation, is what she's saying. So how you pull out, wait. Two x minus x.
So on the ln one, I'm confused as to why she just got rid of the -1.
I'm also confused. I'm confused on both of them. None of it makes sense.
On the left one?
I like how she just says simplify the equation. Here's the answer. How is that simple? Where are the steps? Show me arrows. Okay, over here it helps. So why did the x go to the other side? Oh, because it's in the exponent. Gotcha. Okay. Log base. Okay, that cancels. That makes sense. All right, so the one on the left actually makes sense. I don't know if you guys have any questions on the left.
The right one as well.
Do you guys are any questions on the left-hand one or whatever?
Not really.
No?
Oh, I'm good on the left one.
Peter, is Peter good?
Peter, you good?
I'm just curious how she figured that out on the right one.
So on the right one, if you look at it, the log base 3 to the 2x minus 1, you just take the exponent and put it out in front, so it's 2x minus 1, and then it's going to be the ln of 3 because that's like the base number. And that's good, and then you're going to take the exponent out, put it in front, so it's going to be x, and then the ln of 5 because ln is the big 5. You don't have to worry about the log base 3 because they're both the same, so you just look at the...
Okay.
And so then you multiply it out, so it's going to be 2x ln 3. 3 equals x ln of 5. And then you just separate them out, so it'll be the 2x ln of 3 and the equals the ln of 3. And then divide by the 2 ln of 3 minus ln of 5, and it comes out as your answer.
Okay.
You guys get that?
Yeah.
I got a question for you. 2 ln of 3, couldn't you write that shorthand as like ln of 9?
It's a good
No,
question.
we're taking the ln of 3, and so it'd be the ln of 3 times 2.
Gotcha. Okay.
No, you could, dude. You're right. You could do ln of 9. They're the same,
Yeah. You could do the ln of 9.
apparently. If you're looking for shorthand or whatever, they're both the same thing, so it really doesn't matter. Also, number 4.
Okay.
I don't see a number 4 when looking at the instructions.
Yeah, I think we're done.
I'm good with that.
2.
Is that it?
Claire, you got any more questions?
Yeah, I mean, that's the last of the questions.
So are we
So are we all
to
good on
go
this
then?
stuff?
Yeah.
Do we want to meet on Thursday?
I
Yeah.
assume
I'm
so.
going out of town Friday.
Thursday at 12?
Sounds good to me.
Sounds good.
Austin?
Yes, sir. Yeah, yeah, I'm flexible.
All right, we'll do Thursday at 12 then.
All right.
All right.
Ready,
Yeah.
break.
Awesome. Take care, guys.
Right.
You too.